Welcome back to NMJC and Child Psychology, and I hope your semester continues to go well. Growth and health are on tap this week, with an emphasis on the brain. The chapters Genetic Bases of Development and Prenatal Development, Birth and the Newborn have brought us this far. Remember that all the domains are connected: physical, cognitive, social, and personality. Change in one area generally leads to change of some kind in the others. Chapter 4 is titled Growth and Health. It features 3 modules, and they are physical growth, challenges to healthy growth, and the developing nervous system. Why would we study physical growth? Think back to Chapter 1, where we discussed development in different domains is connected. The brain is a tremendous part of physical development, and physical development in turn affects cognition, social behavior, and personality. That's why we spend so much time on physical growth. Module 1. Physical growth. Children experience growth spurts in the first year of life, and then again in early adolescence. But there is more or less stable growth in the middle. Americans are taller and heavier than previous generations because of better nutrition and health care. As you study the height and weight charts in our book, they often list an average for height and weight at different ages. But it is very important to remember that a certain range above or below is expected. It turns out there is much variability that is within normal limits. Physical growth is a result of both nature and nurture. You probably knew already that nutrition was important for physical growth. But did you know that sleep is just as important? Sleep and nutrition help to translate genetic instructions into actual growth. Earlier in Chapter 3, we learned how newborns need at least 16 hours of sleep. By the time you turn 3, they still need 11 to 12 hours. When your little one begins first grade, they need 10 hours. We've learned that growth hormones are largely produced while you're asleep. And therefore, that's why it's so important to have good sleep. Lack of sleep leads to problems, including impaired cognitive processing and emotional and behavioral problems at school. It's very important to develop a sleep routine with children to help them wind down at the same time every night. Nutrition is always important, but especially during periods of rapid growth. And infants need a lot more calories per pound than you and I do to fuel that growth. Which is better, breastfeeding or bottle feeding? People have debated this for a long, long time. The answer I want to give you is really in 2 parts. Pediatric experts have recommended that breastfeeding is best. And there's several advantages to that. 1, breast milk is generally uncontaminated, and it contains antibodies to help keep baby healthy. When you make the transition to solid food, it's generally less problematic, and on the breast milk, there's less gastrointestinal upset. Now, on the other hand, there will always be some women who choose not to breastfeed, or medically they can't breastfeed. Does this mean that bottle feeding is harmful? Absolutely not. Bottle formula these days is generally fortified with extra nutrients, and you still have the opportunity for contact comfort, which, as you know, goes a long ways toward establishing and maintaining bonding and attachment with baby. As important as calories are to a child, it is even more important that the diet be balanced and represent all the major food groups, and this includes fruits and vegetables. A major problem in America today is that our diets are too high in fat and sugar. This is closely linked to an overall fast food culture. Too many fast food calories lead to obesity, and obesity can further lead to diabetes type 2. This pattern has its roots in childhood, and health experts have seen a shocking rise in obesity and diabetes type 2 in grade schoolers. Module 2. Challenges to healthy growth. About 1 out of 3 children worldwide under the age of 5 suffers from malnutrition. We have children in our own country who don't get enough to eat, but malnutrition here most likely results from eating junk. We know from our research that infants who are malnourished during their first year can recover and show normal height and weight as older children. But what they can't recover from is brain damage secondary to malnourishment and a lack of protein during the first 12 months of life. Malnourished infants are at a higher risk for cognitive deficits, including attentional problems and decreased intellectual functioning when they get older. A hungry child cannot learn. It has become social policy over the past couple generations for schools to provide lunch and sometimes breakfast. For some children, it is the only nutritious and balanced meal they will eat all day. Their performance in the classroom and on testing improves greatly. It is such a wonderful investment for the community on multiple levels. Eating disorders have their roots in childhood. These are largely women's disorders, although they occur in a minority of men, and that percentage is rising in the past few years. Anorexia is marked by a persistent refusal to eat and an irrational fear of being overweight. These girls have a grossly distorted body image, and they see themselves as overweight despite being painfully thin. They'll lose their menstrual period for several months, or if they're at the age where they should start menstruating, it does not happen. Heart problems are a common complication, and while there is some disagreement on the exact number, up to 10% of sufferers who never get treatment will die. Bulimia, on the other hand, is marked by the binge-purge cycle. A binge takes place featuring the rapid consumption of what may be several thousand calories in a short period of time, and then this is followed by the purge. Most often it is vomiting, but it can be through the use of laxatives, diuretics, or excessive exercise. This behavior happens at least several times a week for several months in a row. Both of these disorders have a hereditary component, but low self-esteem, a mood or anxiety disorder increases the risk. A preoccupation with her body, weight, and a history of dieting is perhaps the biggest risk factor. Treatment is available, and it involves many components, including proper nutrition, individual and group therapy, family therapy, and even medication prescribed by the psychiatrist. As I mentioned earlier, obesity has become an epidemic in the United States. 1/3 of adults are overweight, another third are obese. My international students here at NMJC, coming to America for the first time, tell me that this is one of the first things they notice, and they're stunned, they're shocked. Children who are overweight and obese, the number of them has doubled, and adolescents who are overweight and obese has tripled in the past few decades. There's psychological complications to all of this. These children have low self-esteem and they're often unpopular. The medical complications also need to be mentioned. There's an increased risk for high blood pressure and diabetes, and they are virtually guaranteed to be an overweight adult. The thinking previously that children mostly grow out of it is a myth. What is the cause of obesity? Heredity seems to play an important role because it runs in families. And there's a higher similarity in body weight between identical twins compared to fraternal twins. But environment and experience also play a role. We are saturated with advertisements for food. Restaurants serve larger portions of food. And parents may emphasize external eating cues such as clean your plate or it's time to eat, even though the last meal was not that long ago. Food treats can be used as a positive reinforcement for good behavior, and this all starts in the preschool years. These children and adolescents can lose weight by increasing their physical activity, teaching them how to monitor their eating habits. And parents should honestly look at their own behaviors to see if they are maybe unintentionally reinforcing the behavior, perhaps out of guilt. Module 3, the developing nervous system. The human body consists of many different types of specialized cells that organize into tissues, organs, and systems. The cell we are most interested in as child psychologists is the neuron. They come in all different sizes and shapes. This is an artist's rendering of what one might look like. Neurons are messenger cells. They conduct impulses through the nervous system to the brain, in turn to carry out mental activities and behavior. How many neurons do you have? The answer is billions, maybe as many as stars in our own Milky Way galaxy. The most important structures in the neuron include the cell body, which, with its nucleus, is the command and control center of a neuron, the axon, which is a whip-like thread that sends messages to nearby neurons, and dendrites, which are branch-like, if you want to imagine the top of a tree or root system, and receive messages from adjacent neurons. How does the brain know the difference between ordinary messages and an urgent or emergency message? The nervous system can make neurons fire faster. The insulative sheath that provides a turbo boost is called myelin. Neurons normally fire 2 to 3 miles an hour, about the pace of easy walking, but axons coated with myelin can ramp up to over 200 miles an hour, about the speed of an Indianapolis race car. When the neural impulse reaches the end of an axon, chemicals are released called neurotransmitters. These neurotransmitters tell the next neuron to continue the message or to stop the message. This may be hard to conceive, but with billions and billions of neurons and trillions of connections, they don't actually touch one another. The neurotransmitters are released into a tiny fluid space between neurons called synapses. And because there can be so many different kinds of neurotransmitters in the synapse, it can look like a crowded swimming pool in summer. This is a 3D model of a human brain. It's bigger than an average brain, which you can hold comfortably in both hands, weighs about 3 pounds, and is mostly water. It is the most exquisite creation in the whole universe. When you look at a brain from the top, I'll hold it like this, it looks kind of like a walnut, doesn't it? With a strip down the middle and these furrowed ridges. And it also looks like you have two brains, doesn't it? A left side and a right side. More about that later. In the fetus, a baby has an explosion of neurons that are born. And then after about 28 weeks, the neurons are pretty much in place. Different structures of the brain develop. You start with the spinal cord. This goes up inside here. It's hidden, but in the hindbrain you have structures that automatically control blood pressure, heart rate, breathing. It does it automatically. It's unconscious. Another structure in the hindbrain is the cerebellum, this green color right here. The cerebellum, a chief function is coordination and balance, helping to learn motor activities. Think about this. When you climb up and down a flight of stairs, the cerebellum is making constant adjustments, maybe up to 100 a second, so that you pull off that behavior very smoothly and very coordinated. But when you think of the brain, you really think of the cerebrum, everything else here. The cerebrum is coated with the cerebral cortex, about 1/8 of an inch thick, and this can all be divided into lobes. The frontal lobes, right here, going back to here, are associated with language and personality and the executive functions of the brain, making decisions, using good judgment, solving conflicts. From about the end of the frontal lobe back to here, we have the parietal lobes. And these are the primary processing areas for touch and temperature. It helps you to recognize objects without even looking at them. You can do it blindfolded. At the back, the occipital lobes, the primary processing centers for vision, helps you to recognize familiar objects and people. On the sides, the temporal lobe, the primary processing area for hearing, to recognize sounds. I mentioned it looks like we have two brains, and in fact we call them a left hemisphere and a right hemisphere. The left hemisphere, largely responsible for verbal language processing and using logic. The right hemisphere, the chief processing area for visual spatial activities, navigating yourself in a 3D world, and things that are not logical, intuitive, and emotional. With advances in brain imaging techniques, including the MRI, we have learned so much more about brain development in children. For openers, there seems to be an explosion in synaptic connections during infancy, which we call blooming. But if these circuits are not stimulated or used, they're weeded out, and we call that pruning. Another thing is that the newborn's brain is partially finished, and it depends on environmental stimulation and enrichment to fine-tune, particularly the senses. Also, the specialization between left and right hemisphere occurs early in development, and experts suspect it begins while still in the womb. But what I think is most amazing is how flexible and adaptable a young child's brain really is. We call that quality plasticity. For example, if the left hemisphere was damaged or in some case studies, partially or totally removed, the right hemisphere may gradually take over those functions. You just don't see that kind of reorganization in older adults' brains. Well, that's all for now in Chapter 4 on growth and health. I'll see you next time in Chapter 5 when we go over perceptual and motor development. Take care.